Hello. Today we're going to talk about wine data set that Kuanting and we use a different methodology to testify how each factor of the wine could contribute to the wine quality. So as you can see, the dependent variable in this data set is wine quality, and there are 11 other different factors that would somehow contribute to the quality. So the objective of the project is to use different methodologies on the wine dataset to predict which factors are more important in terms of predicting the quality of the wine. So now I'm going to pass it down to Kuanting. She's going to talk about her methodologies.
So the first method that I use is bagging. We can see we have in total 961 sample. And the R-square we obtain in this model is 0.4433, and the MSE obtained is 0.34. And next, I also fit a random forest model. For random forest model, I use cross-validation to help me find out the optimal model. The result shows that the optimal model has M tries equal to 5 and minimum node size equal to 10. Here I plotted the randomly selected predictors and their RMSE. So we can see we have the lowest RMSE with predictors of 5. So I fit another random forest model with n tries equal to 5. And here I have R-square of 0.43 and the MSE is 0.337. And then I also fit a gradient boosting model. The gradient boosting model helped me find out the optimal model with entries equal to 600, interaction depth equals to 5, shrinkage equal to 0.01, and minimum node size equal to 10. So here I plotted the result. The result shows that we have the lowest RMSE of the green line, which is the tree depth of 5. And we can also see that the shrinkage of 0.01 is much lower than the shrinkage of 0.001. And the MSE we obtain in this model is 0.37. So I want to compare the model I got so far. We can see the prediction distribution. Here I have most of the prediction density concentrated around like 5.2 and 5.3. But we have the highest density in the gradient boosting model with the density around prediction of 5.3. And down below, we can see I made a chart to show the MSE with the methods that I use. So I also fitted a regression tree model, but I'm not showing this in the presentation because the result is not very good as compared to the other three. And so in comparison, I have the lowest MSE with the random forest model, which is 0.338. And then I'm gonna pass it to Alicia, and she's gonna talk about the methodologies that she used.
So in here, I use 3 different methods. They're mostly focusing on regressions. So the first one I use are rigid regressions. As you can see, I first plot the data set into a normal regression. So you can see there are the different correlation related to the quality between 11 other factors. With that could better help me to find a better lambda. So therefore, I set the number from -5 to 10 and iterate between the range. As you can see in the graph, lambda equal to 8 it's the most optimal value. So I plot lambda equal to 8 and come up with the MSE that is 0.59. I think it also would be nice to have a tenfold cross-validation to better identify which is the best lambda. As you can see in here, there are 2 lines. One represents the lambda minimum and the other represents the lambda 1 SE. when I plug it into the model, there's not much a difference. So I decided to go with lambda minimum, which is give me a MSE of 0.59, which is not much a difference. I also wondering what is the coefficient at this point, if there are any changes to it, to this. So here is I show the coefficient that related to the quality using rigid regressions. The second method I used was lasso regressions. As you can see, the first step I still plot the dataset into a general regressions to show the coefficient of each variables. As you can see in here, the coefficients still varies, but when lambda equal to 0, there's tend to be the same. So I pick lambda equal to 0 and demonstrate you the most related coefficient or the most important correlation related to quality. And the MSE related to lambda is 0.42, which is a huge drop compared to the rigid regressions. I also use 10 cross validation to show the best lambda. So in here, lambda 1 SE actually have the lowest MSE, which is 0.44. So when lambda equal to 0.44, the coefficient of each factor to the quality of the wine have shown here. As you can see, the importance have narrowed down to 4 different factors. I also think it would be nice to show you the carrot package that has Thalasso, as the lambda have changed between ranges. RMSE have also changed. Depends on that, I have also come up with a coefficient of the factors to the quality using carrot package. So the last method I use is elastic net, which I think is a better demonstration between it's somewhere between rigid regression and lasso regression, because I have a control over the alpha. So I have choose 10 different alpha range to 0 to 1 and come up with different MSE, and I plot into the graph as you can see in here. When alpha equal to 1, I actually have the lowest MSE, which is 0.432. But as I have observed, according to my observation, that is not the greatest MSE we have got. So I'm going to pass it to Maddie, to Kuanting. She's going to talk about, she's going to give you a conclusion on what we have found.
So in conclusion, we have the lowest MSE with the model of random forest. So here I plotted the importance of the variables in random forest. We can see the 5 most important variables in predicting the quality of wine is alcohol, volatile acidity, sulfates, total sulfur dioxide, and density. So these 5 variables will be very helpful when we're trying to predict the quality of wine. And down below, I plot the result into a more friendly way so we can clearly see the importance of the variables. And that's all of our presentation. Thank you so much.